Alright, my little chatty Cathys. Or chatty Kevins, I'm not sure what all. What you are. Okay, guys. You know I do the odds and ends. Okay, so there you are. Alright, so our assignment 4 is due on Wednesday. Okay. I think everybody seems to be doing pretty well with that. Just remember your UT is a one-dimensional array. Your UT delta T is another one-dimensional array if you do it like I did it. And then you're trying to find that U of T delta T. Remember that you're only trying to find the x positions from 1 to n minus 2. Do not hard code your delta x or you probably will get in trouble. Because just because my example delta x is 1 does not mean delta x has to always be 1. If we had a 10 centimeter wire and I said I want 5 sections of that, then my change in my x is 2 centimeters, right? So do not hard code that for me, all right? But we are looking, we are finding in our space, we are finding between 1 and n minus 2, but we are using 0 through n minus 1 to find our 1 through n minus 2. It always takes me by surprise when people shave their beards. You look handsome. Yeah. The 29th place, like, shit, I'm having a hard time hearing you. The 29th, what'd you say? For the nickel and 10.29, the 29th place would be 100. Yes, sir. And we're using that 29th place, but we are never finding that 29th place. We are finding the 28th place using the 27th, 28th, and 29th place of the old one. We're all good on this? Okay. Remember to say floats and your binary file. There's the one thing I haven't given you out of this assignment. I feel like the only thing you're still left with questions about may be how to write to in binary or how to write to a binary file. No, go look it up. Go do some research on it. It's really simple. Binary files in C++. Some people have even said just use the book and they've been able to find it out of in the book. I said I didn't see it in the current book, but maybe they're using it out of a different place in the book. So just search around. It's not, I need you guys to go out there and try. Daniel, give me that look. Y'all are giving me some funny looks like, bacon, I am, woman. Try. If you guys cannot figure it out, come to me and send me your file, okay? Send me your program. I don't want you sitting there scratching your brain for days upon days on just this little tiny way to do for binary, okay? But I do want you to go out there and at least investigate on your own. You need to start getting into reading documentation and trying examples and other things, okay? Because you are going to have classes where you're not given everything, taught everything in the class of what you're going to be having to use in the assignment to get something done. All right? So I need you guys to know what to do when you're in that situation. If you've been in that situation and you're still very frustrated, please send me an email so I can help you out with that. Okay.
I had a quick question. How exactly is the format what we write, like the binary file, and then thread onto the byte graph?
You can have spaces. You do not need any kind of delimiter in there. If you want a space delimiter, you're just fine. It does need to be floats, not doubles, because it's reading 4 bytes of information.
Then just write like values.
Exactly, but do not write your timestamps.
Put a new line after
after each time block?
You can put a new line after each time block, yes.
Is that how it works, or is it knows to look for 28?
It knows to look for 28, and it's looking for flow 28, depending on what you put in there, 28 or 30 floats 50 times.
So that's out the lines and the spacing still work just fine.
It should still work just fine.
Okay.
That's the whole point of it being 4 bytes. Okay, so make sure you're doing floats. Okay, I unfortunately will not be here on Wednesday, and I won't have office hours. I will try my best to answer as many emails as I can on Wednesday, but I do MECOP selection. I'm there from 7:30 in the morning until 8 o'clock at night, or 8 o'clock. Louise, that would be awful. 7:30 in the morning until 5 o'clock, and I try my best, but we get like 30 minutes for lunch, and that's it all day in that process, so I don't really get a whole lot of time, all right? Try to send me emails. I'll try to get back in touch with you. We'll work the best we can on this, okay? Brandon will teach for me. He's probably, since I know where I'm leaving off, he's going to be doing more C and linked lists. Okay, lists. All right? Brandon's the only person I can seem to get to teach for me. Polymorphism. I found out today I have my meeting with my TAs. I found out, which I mean I kind of already knew. Polymorphism gave you the hardest trouble for most of you. Not everybody, but some of you. I feel like I at least want you to, you're going to have to revisit this concept, right? This concept you better revisit because we're having a test. Test 2 will be on Friday, not this week, next Friday, okay? We'll review on that Wednesday before in week 9. And you're going to have to revisit this polymorphism in 00. But I do realize that it's a paradigm shift. And like I told you, with any paradigm shift in your brain, that you're going to have to think doubly hard about that concept, it seems like, because you've got to, number one, put the new concept in your mind, but you also have to make those connections from that new concept to old concepts to be able to justify and understand why you're doing it. Therefore, if those connections did not come until maybe a week or so later, or maybe after you re-looking at a lab or looking at your assignment, you went, ah, darn, that's how you do it. That was the meaning of this. This is what she was talking about. Whatever aha moment you have, you should still be able to get points for that aha moment. You are still learning. So if you have an aha moment and you are able to go back to number 3 and you had points, remember there was like 30 points out of here, right? You missed those 30 points because you just did some kind of workaround so that you would have something to demo with the TA, but they took the polymorphism points off because you didn't do polymorphism. You have a chance to go back and get 20 of those 30 points. Okay? You can do this by your demo time for assignment 4. Okay? You don't need to turn it in to me, but if you can go sit with your TA and justify and show that you understand polymorphism where you missed those 30 points off and you have now had the aha moment where you understand it, you can redeem those 20 of those 30 points back. Okay? This is for all of those of you who decided to make a static object of a go fish or poker, okay, instead of a object on the heap. Also for those of you who got points off by not putting a deck or players inside of the game class, but circumvented that by putting them inside their own deck and their own players, and the go fish and their own deck and their own players, and that totally defeated that assignment, okay? Those are the types of things, if you understand now where you went wrong, try to fix it, okay? I don't expect you to get everything with OO, but at least try to revisit to some degree, okay? I know it's a hard concept, guys. Yes.
We have a final exam, a final project, so
Okay, final exam we do not have. So this test number 2 will take us through all the material where we've pretty much learned, because our last week is go over this test, review, talk about sorting and some things. So we don't have a test because we've already had all the testing. I don't want to retest you on terminology and stuff. So we'll have a project. I will release your project at the beginning of Dead Week. It will be due on the morning of Friday of finals week. I grade that. You turn it in through. You can go beforehand, and you want to do this remotely. You can certainly turn it in remotely. What you will be demoing in your last week, though, is you will require, or no, we're not demoing that. That's right, we changed that. So assignment 5 also will be graded non-demo, so you'll turn that in week 10, probably on that Friday or something is when I'll make that one due. And then the TAs will email you back your grades and stuff. So after week 10 in here, you won't have to demo assignment 5. You don't have to go for a final exam. So if you can get out of here you can leave by Tuesday, because you just got to get something back to me electronically. Okay? I don't know exactly what I'm doing with the project. You all know I come up with things on spur of the moment, so I'm just not really sure.
I was going to ask, that second test comprehensive, or do you just got like visit and stuff?
Yes, it's only the second half of the class. Okay. Okay. We have already implemented. So for your next lab this week, just to give you a preview of where you're going with your lab this week, I will give you the pushback, the constructor, and the destructor that we implemented for our own templated vector class. Okay? You will add to that an at, a size, and the other 2 of the big 3, which are good job. I hear you. Okay, because copy constructor, assignment overload. All right. Yes, those 2 you'll have to implement. You'll also add a capacity member. Okay, and you'll have to really think about what's that pushback going to do that's different now that we have a size and we have a capacity. What if our size is at our capacity? What if our size is lower than our capacity? What if our size and capacity are both at 0? So another thing that I want you to do also in this particular lab is you're going to be graded on test cases. I want you to be thinking about, as you develop things along the way, what is that table looking like in your head? What are you saying to yourself? What value am I going to put in here to test? What result do I get when I put that in there? Is it good? Is it bad? Am I testing things that should give me back that I think are good, and should I be testing with things that I think are bad? What if I say to make a capacity or a size of 100 billion? Did you do anything for that? Did you ever even test for that? Did you even care about testing for that? Okay? I need you to start thinking about these things. You guys cannot just walk around going, let me give a test case of this and this. Oh, yay, it worked for that. Let me go in and just pray that my TAs do not run it with 0, that they do not run it with this number. Don't do that. Get out of that mentality, okay? Go in knowing you have 100. This is the easiest major to know you have 100 in when you go in to have something graded. If you test properly, You always know you have 100. Okay? It's when you don't test properly is when you get bad grades. All right? Testing is very important, okay? So 2 things. The other things I need you to get out of this class besides just the program is that debugging, well, I keep throwing that in, and test cases. How are you testing for things? Are you testing to try to break it, or are you just testing to try to make sure it works good? Your job is to do both, okay? You're trying to break it just as much as you want it to work properly. All right? Okay. So what you're going to do, so this lab, you pick up with the vector, okay? And really, all I can say is that the standard template library, it has templates out there already ready for you to use. But these are templates that are containers. Well, I'll put in here both containers/data structures. Okay? They more relate to this area, okay? That's really the only difference, okay? There are other templated classes given to you out there, so it's not like there's not other templated classes, okay? It's just the fact that the things out of the standard template library just happen to be more dealing with data structures and containers, okay? Called iterators, or you can have them. And so it makes them just a little bit different, okay? We are not going to implement, we're going to use things out of the standard template library, but we're not going to implement our own standard template library class or anything, okay? Because to add that functionality into the vector template class that we did write would be a lot more, okay? So we're not going to go that route. We're just doing the basics of a templated class, but not making it necessarily to fit to this standard, okay? So far we've used vector. You're going to use a list. You're also going to implement your own list. Now, you're not going to implement it as a standard template library or a standard template class. You're going to implement it as a seed linked list, okay? We have these iterators in these things, these classes, and these iterators, before I show you them, they can be of different types. They can go forward, okay? This is in something called a singly linked list. You can go forward and you can go backward in a doubly linked list. So I'm just giving you some examples. And you could do a random access into somewhere. What was this, vectors? Okay. You can have constant, you can have mutable. What do those mean? We did this in Python, if you remember, if you were 160s with me. What's mutable mean? We can change it. Constant can't be. Okay. Sentinel versus non-sentinel. What does sentinel mean? What is a sentinel value?
One that they sure doesn't go out right out bounds.
You can think of that. We could look up the definition. I'm kind of curious what they give us, like far as like Webster, right? Oops, that's not the one. Watchman, keeper, lookout. I think of it more like a terminating symbol or I don't really like these. Keeper, that would be a good thing. A sentinel keeper. I mean, it's not. Remember, I always tell you our term is a dictionary. Okay. But a sentinel value. So your C-style strings have a sentinel value. What's the sentinel value on your C-style strings? The null character, exactly, okay? So that would be your sentinel value. So I look at sentinel values are things that cannot be a true value inside of there. And so they're there as placeholders or keepers or whatever you want to call it to know you got to the end or to know you don't have anything valid anymore. We all know I'm not great with English, okay? That's why I didn't major in English. So there are sentinel values and non-sentinel, okay? And when you use end, you are getting back a sentinel value, okay? Begin gives non-sentinel value. Indeed, what do you think is the sentinel value that end is going to give you that can't be a valid address? No, good job. Perfect. All right, so let's take a visit. And that's all we're doing on this, and then we're headed off into our land linked lists. Oops. I got a big lag in here today for some reason. Okay. Remember, this is our little, we're tri-vectoring. Whoops, and I had done some of this before. You guys, sorry, I hate when I have a lag because I don't know how many times I've pressed X or anything else up here. It kind of messed with me a little bit on these demos. Okay. All right, so one time, right, we did this. We made our own little vector templated class. We brought in vector.hpp. We didn't have that other vector up there. But what if we wanted to make sure our vector implemented class, right, behaves like the one that's given to us out of the standard template library? The one thing we haven't done here, I don't think it's the big deal, and you can surely pick it up on your own, is namespaces. They're just organizational, a way for you to select what you don't want. And so many of you guys have asked me things like this, especially in 161. You asked me, so in this case, if I wanted to test my vector class with the vector class out of the standard template library, right, then I would want to be able to pick which vector I'm using. Am I using my vector from my templated class or the one in the standard library? So here's the one in the top one. This one's from me. Remember, we all developed this, right? This one's the one that comes, our standard one. Now, if I were to, right here, at some point, this is all going to work with me. Okay, so right here, if I were to put using promise I'm typing. If we put using name, okay, what is that going to do for us? Or if we put using STD, am I the vector I want? Or is it going to just automatically pull that vector sitting right there, this V right here, make sure it's standard library? Yes. No matter whether, okay, control this, and this is why namespace is good, okay? Particular point in time. Okay. Then we can say we want here. Oh my good gracious. Maybe I should I'm going to leave and come back because this is going to take me like forever. I'm obviously, as you can tell, there you all go, off on your phones, off talking to your neighbors. Nobody's with me anymore. Even August, he's turning around. We'll come back. I'll come back to iterators in a minute. All right, let me keep your attention. Right? Link together. Yes? Yeah, link together, right? I just say because you don't know if it's arrays linked together, if it's integers linked together, right? I mean, there's a lot of things that can be linked together here. Okay? Why are they different than an array? And why are they different than, say, like a tree? A tree are things just linked together, too. But what is the deal with the linked list? What is it about it?
I don't know.
Is it still? Yes, go ahead.
I don't know if it's the only difference, but I know that linked lists are generally saved, like, in one chunk.
No, they're not, Lucy. Wonderful. They're not. Why is that?
Basically, it's like mentioned, but it's point to various objects.
So where are they?
Where are
Yeah, where are these nodes? Where are these that are all disjoint?
on the edge?
Or where are they? They're not anymore, are they? They're not contiguous. Where are these pieces of information? On the heap. So these things are, and they are all over on the heap. On the heap. All right? Contiguous. So remember, so how do they differ from arrays? Okay? So these are sequential. Okay? But not contiguous. Contiguous. Array contiguous. You start at 0, 100. If you have integers and you're 4 bytes, you're at 0, 104. Right? Remember this? Then your next one starts at 108. Then your next one starts 4 past that. Do we remember this?
112.
Yeah, hush it, Dominic. I hear you. You know I hate addition and subtraction, that kind of math. Well, you know, hire an accountant for that, right? Linked list, guys. Linked list. They go more like this. Okay? This is sitting at 0x100. This is sitting at 0x200. Now, they don't go in this nice little 100 pattern here either. Maybe I'll stick them somewhere else. Okay? That's the difference here. These can be ints. They could be arrays. They could be objects. They could be other linked lists. It doesn't matter, right? It's something along with a pointer here. That they do. They do. Now, let me show you this, okay? If I have a struct, so this thing right here, guys, is what's called a node, okay? So we have a struct node, and in this node, I have something of a type value. Something's in here, okay? In my case, I'm going to have ints. Okay? So we have a value. We also have, what is this thing right here? It's a pointer, and it's a pointer to what type? Have y'all been reading?